Okay, before we move on from this is where we got to, wasn't it, David? This was slide 4.
Yeah, this is as far as we got last time.
Just before we move on, just to sort of pick up on a couple of the things here, because this follows into the next few slides. The first one is inspection as important as testing, and we've covered this a few times. You know our views. Inspection is actually more important than the testing. You can find so much more from inspection than you do from testing. So in some cases where you can't actually isolate a system, you can't turn any circuits off, a thorough inspection is pretty much adequate. Okay, because 85–90% of the faults that you're going to find will be by inspection. The other thing there, the other one that you've got there was, are the inspection records adequate? There's in one of your slides there. Are the forms adequate?
Recorded adequately.
I think what we're saying is that actually we need something else. We need something in addition.
Yeah, and actually, I'm glad you brought this up, because I was just having some chats the other day, and Robert Sadler had a good point to make. He said, the writing of a report is something that we need to start thinking more about.
Yeah.
Not writing passages of nonsense, but writing good, clear reports. And, it might be worth just getting some case studies or examples of reports. I mean, I've done some, and if anybody else has, we can just discuss the best strategies for a clear, concise report.
Yeah.
I was reading Guidance Note 3 just yesterday whilst you were delivering the 7909A, and I was going through parts of inspection. It does say in here, it says inspection, and it then says, and where necessary, testing.
Yes.
Where necessary. So you've got, inspection is so fundamental.
Yeah, and the trouble is, of course, is that people, we have a habit of skipping through the inspection process to get some numbers onto the test sheet, so we can bang out 10 inspection tests a day, or do these things at £4 a circuit, and it's all nonsense.
That is the point, though. It's because the work is complete when the numbers are in the boxes, and to put the numbers in the boxes, you jump straight into testing. The inspection being reported as a tick exercise is an afterthought for the majority. I think the primary objective is to populate the field, which is the boxes of results, to write the circuits down.
Which we can do from the van.
To write, or from the prior reports, to write the characteristics down, to then populate those numbers, and that's what's then recognised as a successful inspection and test, and that's what obviously passes and completes contracts and gets people paid. And the inspection just being currently a tick exercise, it really overlooks the importance of inspection, I think.
I think it's a case of, using your terminology, we've got to think about levelling up this whole industry when it comes to inspection and testing, and the documentation that we tend to use, or is popularly used, it puts too many shackles on people. They're blinkered by the documentation. We need to go beyond that and start looking at report writing and doing additional sort of indications of faults and problems, and looking further than just the C1, C2, C3, FI, limb, all this sort of nonsense. We need to look further than that, and it just doesn't work. It's not fit for purpose, really, on some of the installations that we're going into. Okay.
Yeah, there's guys in the chat. Richard says, I have a purple folder, $1.99 with a sticker on it. I pushed the boat out. But that's it. It's different from the norm. The generic forms are, and you can populate that folder with all sorts of material and information of reference. We mentioned, was it the last one of these or before, about the idea of doing a drawing with the wiring systems, the directions of the cables in the walls. If you're going to hand over to a domestic client, you can show them a photo or a photo of their kitchen. You can draw on there where the wires are. So when they have work done in 5-6 years' time, they can hand to their contractor, this is from the previous electrician. If those were not a good idea, but actually a standardized practice, we'd have a lot of incidences not occur.
But it also comes back to, there's a lot of people that just do the absolute minimum. Fortunately, there's a number of people that go beyond that and think about it ethically and want to do the job properly and give as much information as possible. But there are cost, and there's a lot of sort of pressure for people to do the absolute minimum, get in and out as quickly as possible, okay, and get on to the next job. And we've got to try to discourage that sort of process, that practice.
Well, again, I go back to looking at who we would say would be the caretakers of industry, the people who authorise this work. They've got to tighten it. I said a few years ago, if EICRs and these documents were each individually tracked and recorded, and you could then just sample them instead of them just being kept in-house, there needs to be something that allows anyone doing this work to realise they have to hand that evidence over. So I could see I think of like software such as Ryan from TCW. It would show me how many reports an individual is doing. And I could immediately go, well, hang on, let's look at those because you're hammering them out. And if we track or if we license or if we control people better, then they won't have such free license to just abuse it. Slow it down and let the clients then take that on board. Anyway, we go on to the next slide, which we didn't.
Why not? Let's break new ground.
Let's go. We're now going to go into a pictorial presentation, and you're going to talk about this. Before we go, did any of you guys come onto the webinar where we talked about fire? Any of you guys come onto that? Yes. No. Yes. A couple of a lot of yeses. All right, cool. All right, so a couple of notes. So you can make this fairly brief. Pop this next slide. There's a lot of yeses. The video of the recording of that will be uploaded next week, though, for those who haven't seen it.
Okay, right. What we're looking at here is, again, this is all part of your inspection process. You can't do this by testing. This is a case of sticking your head up in the ceiling. Find a hatch, stick your head up in the ceiling, look above the ceiling, and look to see how cables have been run. And obviously, we've got this alteration to the regs where we've now expanded from, okay, you just need to worry about cable supports in evacuation routes. You've now got to look at cable supports throughout the installation. And this is obviously due to the tragic events where firefighters have died because they've been caught up in cables. Anybody that watched the presentation we did, the webinar we did, will have got the full picture. And as I say, David's going to bang that up on his YouTube. Yeah. So
we are rerunning the webinar again next week, aren't we?
We will be. Yeah, we are doing that one again actually next week. So if you did miss it and you want to take part in that one, please do jump on. For my sins, when I was younger, fitter and leaner, I was a firefighter for 18 years. Retained, I carried a pager, so I carried out my duties as an electrical contractor, and then I did firefighting, bit like going out on the lifeboats. So I had 18 years as a firefighter, and 9 years of that I ran a fire station. So one of the issues that we've seen with this business of premature collapse, okay, is people talking about, oh yeah, it only needs to hold up for 20 minutes or half an hour to enable people to get out. If you read the regulations, if you read the terminology, and if you look also in the guidance notes, it says about firefighting activities. How long is a firefighter in a building? Well, actually, firefighters will be in that building for hours. Okay, they'll be searching, putting out the fire. They'll be looking for other hazards like gas cylinders, looking for hot spots, dousing down, working in smoke and flame and fume and whatever for a number of hours. Okay. What a lot of people don't realise is the conditions that firefighters are working in. Okay, imagine going into a building, and this is how we train in the fire service. Imagine going into a building and shut your eyes, and you've got to find your way in and out of that building and search it with your eyes shut, because that's all you can see, nothing. Yeah. Everything is done by feel. So when you go in, you follow a wall. Now, we might go into a building and look down a room and think, well, if we're going to go out that door the other end, we'll just go straight across there, and that's what a firefighter would do. Well, no, the firefighter can't do that because he can't see the door. He has to follow the wall. So whereas we might think, well, this is an escape route, or we need to really worry about the cables in this area, the firefighter won't be following that. He'll be following the wall.
See, I've been guilty of that. I've gone to a room, I've gone, right, the door is over that way, so the firefighter's going to go from this door across that way. I then consider above that walk route, any potential cables. I wouldn't think that he's actually going to walk around the boundary of the room.
He's got nothing else to guide him, or he or she. They've got nothing else to guide them. They've got to follow the wall. It's all done by touch. So everything's done almost with their eyes shut because they can't see. There's a thick layer of smoke in there. You can't see a thing. Quite often, when we go into a building, you'd actually be on your belly. You'd be crawling on your belly because you'd be trying to look. Yeah. Eleanor, yes, well done.
Thank you, Eleanor.
Yeah, we were actually the first station in Berkshire to have female firefighters. We had 2 on our station when I was the station commander, and they did a sterling job. So yes, if I say he, that's just me being old. It's very much a multi sort of sexual activity now. Yeah, so when you go into a building, you're going to be on your belly, looking across the floor. So that's where the clear layer is. So anybody who's standing up is going to be in smoke. They can't see where they're going. So you're really, really, really struggling, for vision. The firefighter, what we used to call it the BA shuffle, okay? And so you're going along, you can't see what you're doing. You've got your hand on the wall, keeping contact with the wall so you can find your way across. And you've got your mate next to you, okay? So, and he or she is actually in contact with you, and they're doing the search while you're keeping contact with the wall. And the way we search is by putting your foot across the floor, okay? First of all, you've got to check to see if the floor's still there. So whereas you and I would be stepping over cables, because we can see what we're doing, any cables are on the floor, a firefighter will be sweeping their foot around them, in amongst them, okay? Because they've got to check the floor's still there, okay? Mm. Obviously, as they're doing that, any cables on the floor they're going to get tangled up in. Any cables that are hanging down, they've got a BA set on the back. And as they're walking around, okay, these cables are dangling down. If they go backwards at all right, and sometimes if they're going forwards, the cables will get caught up. Now, when you go up a staircase, your eye will go up forwards and come down forwards. A firefighter will go up forwards and come down backwards. And again, that's because as they're coming down, he or she has got to test the steps behind them. I mean, I was quite a weighty person, always have been. Okay, so any weakness in that staircase, any weakness in that structure caused by the fire, would maybe cause the staircase to collapse or a stair to go. And if you come down forwards and that stair goes, you're going to go headlong down the stairs. So firefighters always come downstairs backwards. So you imagine you've got somebody coming down backwards with a BA set on, okay, and that's sticking out, the tank sticking out at the bottom. You've got cables dangling down over the stairs. As they come down, they're going to go up underneath the BA tank, right? And the only time, the first thing the firefighter is going to know is when they feel the restriction of those cables, okay? Then natural reaction is to sort of turn around, all right, to try and get rid of it. You've got to remember also they've got big thick gloves on. I personally, I don't even like wearing gloves on site when I'm doing electrical work, let alone wearing these thick gloves where I can't see what I'm doing and then try to untangle myself. And then the final thing, I don't want to spend too long on this because this is, we're looking at EICs here. The final thing to think about is we talked about flashover. And firefighters are trained to look for flashovers. So this is a situation where we get pyrolization of all the material within the room because of the heat that the fire is sending off. And at a certain point, that whole room will basically explode into a fireball. And there's early warnings of that. You can see dancing angels going across the ceiling. You can tell from how the behavior of the smoke layer is going. You can tell by the actual heat buildup. And the firefighters got a few seconds to get out of the room, should that happen. Okay. Any impedance to that exit from the room, they're going to get trapped in there. When a flashover occurs, the room temperature will go from between 300 and 400 degrees up to 1,000 degrees. Okay, so if that firefighter is still in that room because they've been caught up on cables, even for a few seconds, that might be enough to delay them getting out of the room, even for a few seconds. If they're still in there when that flashover occurs, they'd be very, very lucky to survive. Okay, so these are the sorts of backgrounds to when I look at these situations where we've got cables above ceilings and you see these sort of horrible bird's nests of stuff. And we know it's not always electrical cables. It could be data cabling, it could be comms cables, okay? But if I see electrical cables, and the argument we have is, yeah, but the regs is not retrospective, okay? I personally step back from the regs and I think to myself, health and safety at work. If you see something which is dangerous or potentially dangerous, you have a duty to do something about it. Electricity at work regulations, okay? You've got to work safely. If you see something that's not safe, even if it's not your work, you need to do something about it. Okay, so let's put the regs to one side for the moment and just think health and safety at work and electricity at work regulations. These are statutory documents. This is legislation. We have a duty of care if we see something which we think could be potentially dangerous to do something about it. Okay, and the argument, yeah, it's not retrospective. We don't have to do, you know, we can ignore it. For me personally, I can't ignore it. I see that and I see a possible hazard. Should that building be involved in fire, firefighters are going to go in there and somebody's going to lose a loved one. They're going to lose a son or a daughter or a wife or whatever. Okay. And if I can't come out of a building having done my utmost, and I think to myself, should there be a fire and somebody does lose their life or get injured, am I happy to stand next to their family, next to their husband or boyfriend or girlfriend or mother or father and say, well, you know, it wasn't retrospective, so what do you want me to do about it? Yeah, and they died because they got tangled up in the cables that I ignored. That's what I think to myself, that's how I'm going to approach this. If I see those sorts of things, then I'm going to take action. Mm. The problem we've got is, we're shackled. Is it a C1? Well, no, it's not immediately dangerous. Is it a C2? It's dangerous under fault. Well, yes, if there's a fire, it could become dangerous. Is it a C3? Requires improvement. Well, we know what happens with C3s. Most companies will ignore them.
The struggle with the coding is understanding the risk, because like, even in the codebreaker book, they give it a C3 if it's conclusive that the risk of the cables dropping will not create a risk of entanglement to the firefighters. Is because it's for the firefighters that the regulation is there, as covered in our previous webinar where we go through the Shirley Towers, Harrow Court, and the other Sidon Stour fire and the coroner letter 43s. But as you just described, unless we actually understand the behavior of firefighters tackling fires and not just going across the room to the next doorway, how do we determine the risk of entanglement unless we can just guarantee the cables will not drop? Or if they do drop, they actually, you know, they're going through the structure of the building and they're staying up high. And you could have cabling, you know, that's actually at waist height, and you could end up stumbling on it if you're going around the boundary of a room. It really is it's an area that we've not had kind of education on firefighting behaviour to determine what the risk of entanglement is. You know, you also mentioned, you know, cables above a plasterboard ceiling in the webinar. You know, we know if we look in the building regs books and stuff, we're supposed to clip the cables. We're supposed to obviously run them through the joists. But, you know, we hear from the industry that, you know, a plasterboard ceiling is adequate protection. But well, that's the way to escape for the tenants of the property. But as you said in the webinar, you know, the first thing firefighters will do because of the risk of the flashover.
Flashover, yeah.
Is you'll throw water onto that structure, and if it's really warm, it gets, you know, many times the plasterboard comes down. You said.
Firefighting activities, obviously, 99% of the time, firefighters will use water. If there's a risk of flashover, it's in controlled pulses and stuff like that. That was the training when I was in. I've been out of the job for a number of years now, so it may have moved on from there. You know, technology moves on, ideas move on. But what we used to do was crack the door open, and then you'd have a team with you, and then one of you would hold the door, and your partner would aim a spray of water or a jet of water into the smoke layer at ceiling height. Okay, so while she was doing that, giving that a couple of pulses, you would control the door. If you felt anything going on, you'd slam the door quickly, and you'd cool the room as quickly, or you'd have a stage of cooling the room before you went in. Okay, and then you'd go in and do your business. Once you've got over that risk of flashover, then it's a case of, how do we put the fire out? Well, we chuck loads of water on it. Okay, and I'm talking gallons and, you know, hundreds and hundreds and hundreds of gallons of water going into a building. What's that going to do to the plasterboard? You know,
Yeah.
we talk about plasterboard being, oh, it's okay for 20 minutes, or you know, it'll hold back a fire. It might well do, but you go chuck in loads of water on it, and it will eventually collapse. Okay.
I mean, how many times did you see a ceiling collapse in your time in the site?
Pretty much most of the time. If you had a serious house fire, and you went in there and you're using lots of water, okay, you're very, very unlikely to have ceilings that were intact.
Right.
Afterwards, you know. So at some stage, if your cables were going 90 degrees to the timbers, you know, the joists, then obviously they'll be supported by the joists. If they were running parallel to the joists, then they would sag down if they weren't clipped. Okay, and even sometimes if they were clipped, so we know that plastic clips don't survive. But the issue is, of course, if you're at 90 degrees and you're actually being supported by the joists, you know, we talk about drilling the joists and putting the cables through there. Okay. And then people say, yeah, but what if the joists collapse? Well, I'm not being funny, but if your joists start collapsing, you've got structural collapse of the building, your firefighters are not going to be in there. Okay. If they got structural collapse of the building where timbers are coming down, yeah, and walls are coming down, the fact that cables are coming down with it is probably one of the, you know, okay, well, we won't worry so much about that. We're being hit by tons of wood and brick. Okay, so at that point, they shouldn't be in there. So we're not talking about, okay, do we need to worry about the cables going through the joists? If the cables are going through the joists, they will be supported until such time as you have building collapse. Okay, what we're talking about is ceiling collapse, suspended ceilings, plasterboard areas, okay, where they get loads of water on them, they will come down. Yeah, if they get heat, suspended ceilings, you know, the frameworks will buckle and they will collapse. They'll be on the floor.
Just going to look at the chat for a couple of secs. There's a couple of questions where I came up with this.
The issue we have is obviously the coding of it, because if you give it a C2, if you apply a C2, then obviously it means you've got to take some action. The trouble then is if you've got a suspended ceiling, it's fairly easy. You can get in to put some supports up, some metal supports. If you've got access into the ceiling from other points, great. But if you've got a large ceiling area where you've got no access into it, but you can see across and you can see these cables, but you can't reach them. If you put a C2 on it, you've now got a situation where you've now said the building is unsatisfactory, so it might lose their insurance and everything else. And then what can the customer do about it? What can you do about it? Well, you can't actually reach it unless you take the whole ceiling down.
I end up saying this a lot when we talk about this kind of work, and I'm going to say it again, the coding that we have is too restrictive.
Yeah,
it's too harsh, and it forces us, because, you know, we go to a site and we won't want to give it this code because of the conclusion. So this kind of scenario, if it is considered as potentially dangerous, then the code is relative, but we don't want to give it because suddenly we're going to say something is potentially dangerous that's been up for 10, 15 years that we've assessed before, which we said wasn't dangerous. And that's going to influence our opinion of these. As Peter says, you know, we need to be able to apply our engineering judgment on these scenarios. And if I say it's a C2, I should be able to say it's a C2, potentially dangerous, provide sufficient risk assessment information for the client, but that shouldn't force my hand to make it unsatisfactory. You know, it's too restrictive. It depends on the information and the knowledge the client possesses in control of their system post your work. And this is where we got to with the webinar on this subject. We started talking towards the end about, you know, handing this information down. Some guys in the chat at the time said it should be like an asbestos register equivalent. Yeah. Where the site has a log of all the wiring systems that may be subject to premature collapse, so they can gradually be improved. Because as you said in the previous webinar, we can't just suddenly go, you must take your ceilings down and fix all those wiring systems. It's not reasonably practicable. But we need to identify the element of risk. We need to be able to then control that, either with a plan of improvement or something. But to safeguard the firefighters in the future, we need to give them evidence, or we need to have some kind of relationship. So, you know, factories I work at, there are guys in charge of fire risk assessments. Those are the guys that get me in to do the thermal and to do that kind of stuff. They want to know this because they're supposed to have that relationship with the local fire authority.
Yeah.
They have that communication with the local fire authority. So they should have that information for them.
Yeah. A reasonably practical step would be to, if you cannot physically get in there, to do something about it. And we've talked before about, and I keep using the term linear clips because I've seen the linear clips and I like them, and they do the job and they're British made. And
you just can't remember any others, D-Line, Firefly, and all the,
So I use the term linear clip because I like them. Others are available, but you know, if we can get in and put, we don't have to. It doesn't have to be every support. It needs, you know, every now and then. What we're looking at is to try to prevent the cables from sagging down should the plastic clips collapse. So it doesn't have to be every clip. It could be every 3, 4, whatever clips, depending on the size of the cables, okay, and the height of the ceiling. So as long as we support those cables up above a position where, you know, people are going to get entangled in them, okay, then that's fine. If we cannot physically get in to do that because we've got a huge ceiling area with no hatches in it and we can't physically get in to do it, then what we should be doing is taking the reasonably practical steps of doing a survey and a report, giving that to the customer. They can then add that to their fire risk assessment. Okay, as a firefighting, turning up at a building, you know, I was 9 years in charge of the station, so I'd quite often turn up in the pump. I'd be the officer in charge of the incident. The first thing you're looking for is there any life risk in there? Is everybody out? What products have you got in there and everything else? What's the structure of the building? Where's your fire risk assessment? What information can you give me? And if you could then, you know, get a document from the building owner that says, okay, well, here's all the likely risks, and including in there areas within the building where we know there's unsupported cables, yeah, then when you're sending people in to search a building, to damp down and stuff like that, you know, we'd often send guys in teams, all right, so we'd have the first team take a right-hand wall, second team take a left-hand wall. You know, you can't say to them, go down to room number 20, because they can't see, yeah? You take a left-hand wall, you take a right-hand wall. If you've looked at this building plan and it's been highlighted, there's areas in there of unsupported cables, you can, within your firefighting plan, send teams in to avoid that and at least communicate to the teams, you know, try to keep out of those areas there are unsupported cables. The more information we can give the firefighters, the better it is. Okay?
And if they have to go into the area, you can just increase the communications and things, can't you?
Well, yeah, just warn them. You know? Because the other thing is, I mean, the job was changing when I came out. You know, years ago, we just did turn up at a building and just chuck the guys in there and put the fire out. Then it got to be, okay, you need to do a risk assessment, and if there's no life risk, we're not going to send people in. We're not going to risk lives if there's no lives to save. And so the officer in charge, he or she will take that decision, and you know, if there's nothing there, no reason to go in, then the officer in charge, she'll just say to the crew, you're not going in. We'll just stand back. We'll pour on water from the outside. We'll protect the surrounding buildings and any other risks. Okay, so this information that they need. So that's my opinion of that. You know, the codes we have do not work.
Okay. Well, a couple of little points here then. Duncan says, should we be designing for the fire service entry and egress of the building and not for those that utilize? So when we do designing, should we be considering firefighting a building? Does that come under the requirements of designing a system not to spread fire? Should it be part of that? Where we think about designing a building not to spread fire, should we also think about firefighting activities in our design?
I think whenever the building is designed, we should consider all possible sort of risks and hazards. And one of the risks and hazards is, should there be a problem in there, like, I mean, you know, it could be water, not just fire, it could be water, it could be all sorts of things. You know, if we have burst pipes, you know, and this is going to come down, this is going to come down, we should be considering all sorts of hazards so that our design is fit for purpose and use, but also we should be looking a little bit beyond that. Again, it's one of these things, you know, you use the terminology all the time, level up. Let's take it up a stage. Let's not just do the minimum. Let's include, you know, other factors. So yes, think about firefighting activities. Think about what's going to happen if the building collapses, or this happens, or that happens. Include it in the design. Make it robust. You know, design should be robust and fit for purpose. So,
right. I had a quote I was going to read out. Okay, Steve, network cables. So network cables, they don't technically form part of our EICR. So if our EICR is regards to the low voltage electrical installation, data obviously is often excluded from the scope of that. So if we pop up and observe issues,
we still need to report on it.
Is it within our remit?
I'll come back to the health and safety at work and back to the electricity at work regulations. We've seen a hazard, we've seen a likely risk, we need to report on it. It might not be our responsibility okay? But we need to report it to the customer. And what we could do is say to them, this is a serious risk, this is a serious hazard, okay? Although it's not electrical, do you want us to make it good as far as we can? Okay,
so would that, in your opinion, just go under other comments, or do you think that it's a codable thing?
Again, it's a case of let's put a report in.
Yeah.
Because the documents, the shackles we've got with the documents we've got do not work. We need to be starting to write reports.
It does seem to be a common conclusion that, you know, we're trying to adjust the way we do the work to fit it on the form. It feels as if we need to just be freer with the paperwork.
It's not fit for purpose.
Then, you know, capture what we want to do. Okay. I'm just pushing through so we can move on. And there's a great question here from Andrew which I want to come to, which is on a different subject, which is good. So Peter says about engineering judgment. Andrew uses metal staples for above the soil. Peter says, regarding timber and plasterboard joists, I still use plastic clips, but I deploy all-round band in strategic places. Okay. There's more people talking.
This is it. You don't need to use, you know, a metal support every space. You can space them out, so that will, you know, reduce the amount of time and cost. But every now and then, just give it sufficient support, and that all, as I say, it all depends on the ceiling height and lots of other things. So
and Paul says London Underground, obviously, because they learned from that, and Paul will be very well versed.
Well, that was the King Cross fire, wasn't it?
Yeah,
21 people died, and this is always the thing: is that we kill people, then we learn from it.
And Paul says, obviously, network cables are ELV. Yeah, so they are technically within the reach of our EICR, but why do we always kind of put it outside of our scope, don't we?
Well, we ignore it because we didn't put them in.
Yeah.
And this is the thing: we don't take ownership of a hazard because we didn't put that in.
Does anyone,
and that's a bit.
Anyone in the chat do data installations? Is there a separate reporting process in that area of the sector, or is it, you know? Let me know. I mean, I've done it as an additional part to just electrical work. I've not done it specifically. You know, is there a separate reporting practice for data? I don't know.
If not, why not?
Yeah.
Okay.
Yeah, we do need to move on.
Great.
No, several no made me aware of. Oh, okay. A couple of say no, but I suppose no, but it's supposed to be soon.
It's coming soon. That'd be good. Yeah.
That'd be interesting. Okay, I'm going to read Andrew's question. When compiling reports on larger installations where you have main isolators, busbar chambers, and multiple distribution boards, I always do a circuit chart for each switched isolator, busbar, just NA the fuses. By doing it this way, I can suitably document each submain cable size and have full distribution board schedules. I've had disagreements with an old CPS inspector, as in his opinion, I've recorded information that's not required. I still do it this way because it's there, and is there another method you guys use? I don't think you can ever report too much information, in my perspective, as long as the information is accurate. I got into this situation when I did some thermal imaging for a company. I put in a quote about 5 years ago to do a thermal imaging program for the company. And I said, well, I'm going to do the work to ISO, blah, 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 blah. But I'm also going to do arc flash calculation analysis. I'm going to create drawings of your electrical system, much like you've just explained there, Andrew. And I'll be recording on those what the arc flash values are, what the required levels of PPE are with consideration of NFPA 70E for the calorie value of the PPE. And when they threw that across to the competitors, they're like, you don't need to do that. Don't need to do that. And then they came back to me and says, they said that you don't need to do it. And I said, well, ask them why. And they didn't have an answer. You know, so some people will think, you know, you're doing too much work. I don't know if there's such a thing, in my view. If you're giving information to the client, if it's resourceful, if you're recording good information, that's what we don't do enough of. The amount of times you've been on a site and there's just no information to work with.
Well, this is the trouble, isn't it? And the thing is, we've got to start thinking about this. I was just looking around for my folders that I've got on the job that we're on, or we have been doing over the last sort of year or so. Yeah. We're doing an inspection and testing. We're doing the periodic reporting, the stuff, condition reporting. And I've actually built up schematics and block diagrams showing all the switch rooms and the supplies out and where they're feeding to and stuff like this. It wasn't a requirement of the actual specification of the job, They just asked us to do the inspection and testing and do the condition report.
I'll
But
get
when I actually showed that to the facilities manager, whoa, this is fantastic, you know. So it's helped me because it allows me, when I'm back in the office and I'm thinking, hang on, how was that? You know, I can go through my own block diagram and I can remember and understand the system. But also to be able to provide that to the customer, and they think, whoa, this is fantastic. We never had this before, you know. So it's good for marketing. It's good for your own business. You know, it makes you step out above the crowd. So I always, you know, as much as I can, I'll produce schematic diagrams and drawings and stuff. It helps me, and it also is good for the customer. It looks great.
I'll put a picture on Instagram of something I did before. We are going to move on to the next slide now, but there was just one comment, and we'll comment on it as it's there. Dave Lewis, the NICIC told me that a plasterboard ceiling is a fire barrier and metal supports are not needed for cables above.
You know me with the NIC, I'm sorry. I just, I have to be careful what I say.
Is a plasterboard ceiling a fire barrier for a firefighter who's tackling a fire?
Generally, a plasterboard ceiling, just like an internal door, we generally say that will hold back fire and smoke and flame for 20 minutes.
Right. Okay?
But remember, firefighters are going to be in that building for hours. You know, this is a difference between getting people out of the building. This is the initial stage of fire protection, is let's try and get people out of the building initially. So what we're looking at is to keeping everything safe. So having plasterboard ceilings, having fire doors and stuff like that. Even an internal, just an ordinary internal door within a house will hold back the flame and smoke for 20 minutes. That gives people time to get out. Okay. It also means if somebody's trapped in a room, the fire brigade have got the potential opportunity to do a snatch rescue from the window, you know, and the fire should be held back. But we're talking about 20 minutes. Okay.
The problem is
just getting people out. Firefighting activities take hours.
Yeah, and this is what always boggled me, and that's why I did the video 2 years ago. Everyone was advising with regards to consideration of 20 minutes, 30 minutes, maybe even up to 90 minutes for escape. The building's system is obviously fabricated to maintain its integrity for your escape. Firefighters who then go to a fire, if there's someone who's unaccounted for and the decision is made to go in to tackle that fire, you're there for a period way beyond the fabricated design for escape. And that's where these guys have died. You know, these guys died sometimes in minutes. Atherstone Stour was hours. The building was evacuated. They went into an evacuated building to try to find the source of the fire. And the roof came down and the wiring systems were coming down. And the firefighters that made it out of there reported that the wiring systems compromised the ability for us to get out. So the conclusion was they either suffocated or they died from the roof coming down. You know, if we just say, oh, you know, plasterboard ceiling's just 30 minutes, you'll be out by then, that's not a problem, cable up there is fine. The regulation is there because firefighters died tackling fires.
Yeah.
So
well, the biggest fire I ever went to was Windsor Castle. Okay, I was at Windsor Castle. That started on a Friday. Okay, we went on a Friday. We were still there on a Sunday, so we would be relieved every now and then. Okay, so you'd have a crew turn up and they'd do a stint of 6-8 hours, and then you get a relief crew. You go home, get a few hours kip, have a bath, and then you get called back in. Okay, so it started on a Friday. We were still there on the Sunday, damping down and putting the flames out. So where's this 30 minutes or 20 minutes come from?
The regulation came in due to Rule 43 letter because coroners wrote to improve it to the building regulations because firefighters died. That's why the regulation is in there. Yeah. So it's
the regulation says firefighting. Yeah, it says firefighting activities. Firefighting activities can go on for hours or even.
And it also mentions that in your guidance note 4, is it, that you've got?
Yes. Yeah.
Yeah, it mentions it in there, and it mentions it in 5839. In I don't know 22F or 26F, one of those, about, you know, wiring systems collapsing. So the only example I can see to this may be if you're going to a simple house, if you're going to a simple home and you arrive and the wiring system has obviously maintained its integrity because the plasterboard is still up and they're out, then technically that's fine and you won't go in. But if you're either at home and no one is out or everyone is not out, you're going to go in.
If you don't know, if you're not absolutely sure, okay, then the tendency would be to go in and do at least a quick search, okay, while you can. And the thing is you want to get in as quickly as possible before the smoke layers and the heat and everything has built up and the fire's grown. So if you don't know, and the trouble is you turn up sometimes at a house and the neighbours will be saying, oh, there's a family in there.
Yeah.
Okay. And then you find out the family are actually out, but the neighbours don't know that. So if you as the officer in charge of the incident, you're being told by the neighbours, oh, yeah, there's a family live there, I'm sure they're in, okay, and you can't see anybody, then you are pretty much, oh, well, we're going to have to go in because we believe there's a life risk.
Well, that's the instinct, isn't it?
Then when you go in, the family turn up and come back from the shopping and think, what are you doing in our house? What's going on?
But I mean, the guys,
right, get everybody out.
The guys at Harrow Court that died, remember, they actually kicked the door in without any water in their possession because they could hear someone on the other side of the door.
Yeah.
You're at a door, you can hear someone on the other side of the door screaming for help. And clearly that's what they do the job for. They want to help people.
Firefighters will go in if they think there's any life.
There's a life to save.
If there's a life to save, they will go in. Okay, and you can't stop them. They will go in.
Yeah. So again, coming back to EICR's industry guidance, I think it's very skewed and it's very misinterpreted, and we're not hearing from firefighters. We're not being told by firefighters how firefighters tackle fires, approach fires, about what it's like, and the information is, in my view, false, and that's why we did that webinar on there. Okay.
Yeah, I mean, my advice would be wherever we can, get in there and support the cables. Just put some linen clips or some sort of metal support in to stop the collapse or stop them dragging down. If we can't get in there, we need to write a report and hand that to the customer, to the building owner.
I mean, Sean's just mentioned here about, is there an alternative to things like, the sheet plasterboard, if it was to use 120-minute rated ceilings because of the risk of the plasterboard in terms of its weight? I mean, to firefighters, they're happy for the plasterboard because that's a large obstructive thing. They can just move that out of the way. Can they work around that? And maybe a suspended ceiling grid, they could work with that, but not cables. Is that the problem?
The issue we've got with all these materials is, we talk about plasterboard, and we're always talking about fire protection and how durable it is within a fire situation. We put a fire in a building, okay. When they test these things, they'll use a crib. You saw that in the video the other day.
Yeah,
there's a crib, okay, and they'll set a fire up, and they'll see how long the plasterboard ceiling will restrict the fire, and then maybe the internal door, how long it will hold the fire back within those conditions. Mm-hmm. But if at the same time as the fire going on, you've got firefighters the other side of the plasterboard chucking loads of water on it, weakening it, okay, that duration is going to be reduced. And this is the thing, is that you've got multiple things going on. You've got fire going on, okay, which is damaging the plasterboard, weakening the plasterboard. You've then got water going on it, which is damaging the plasterboard, weakening the plasterboard. Okay, so these things, when you get firefighting activities going on, these things are going to collapse. They're going to come down. I don't think, when we look at these things and say, okay, if we put a longer duration plasterboard in, will that help? Well, it possibly would help. Okay, but you don't know how long the firefighters are going to be in there. So I think rather than gambling on it, support the cables where we can. If we can't support the cable, we can't physically get in there to do it retrospectively, make out a report, identify it and report on the areas where you've seen cables that are unsupported that are causing a risk.
Right, well, we're going to move on because this is one slide and we're nearly at we're on the o'clock of 12.
Are you joking? Go on. Let's have another slide.
Let's have another slide. Now, guys, we did a webinar just on this subject, and I'm going to upload the video next week. I may even rush it.
Well, we're doing it again.
We're doing it again, where the webinar is dedicated to this thing, and we're going to go through the 3 scenarios: the firefighters that perish. We're going to talk through firefighting activities. I'm not saying we're right or wrong with this, but I'm saying we need to think about it from the firefighter's perspective, because that's where the regulation come from them dying. And we are restricted with codes, but we need to. The conclusion of the webinar was, the idea of reporting or creating some information to the client to help safeguard firefighters later on. Let's move on to another slide.
Hey, a different slide. Wow.
Oh,
okay.
Okay. Right, we can do that. I took this picture a number of years ago when doing an EICR. It's a metal sink with a socket that was put there. This was a large sports complex, not long been built, and I was doing testing just as it kind of had been finished. Was it an EICR or was it an initial verification for them? I can't remember now.
I think it was an EICR.
Was it an EICR? Because they didn't have any paperwork, did they, or something?
If it's the place I'm thinking about,
it's the place you're thinking about.
Yeah, right. Okay. Well, the initial verification. Let's say it was a bit
loose,
bit airy fairy. The initial verification. Yeah.
Lawrence, I'll answer that question towards the end. I'll just come off the presentation thing. I think it's letter 43?
I think so,
the
yeah.
coroner thing.
Yeah.
I will find info for you. So this is a socket installed in a servery area, and there's a huge metal sink, and it's all plumbed in, and you couldn't, and next to that socket is actually a data point, and clearly the use of the space has changed from the initial design. So hopefully. So I carried this test. All this is a continuity test from the R2 of the CPC of the socket outlet to the metalwork of the sink, readily accessible metalwork. Yeah, not looking for the closest point of earth, but a piece that the user of that location can touch. And the reason I did this was to obviously look at the need to consider 415.2, because we have an inspection checklist to tick to confirm that supplementary bonding is present if needed, etc. But the question is, do we actually go around locations and actually say to ourselves, can we touch exposed and extraneous conductive parts simultaneously, or exposed conductive parts of different systems even, which we think about in temporary systems? And there's little to no coverage of this or mention of this or application of this in the 2391. And I see very little evidence of this on sites. And I'm going to say this because I'll walk around and I'll see an absence of supplementary bonding, and then sometimes I'll see a presence of that. And I'll always be asked, do we need it? Do we not? Yes or no? I get asked the yes or no. And fundamentally, the question is, if somebody is at a place of work and they can touch simultaneously accessible exposed and extraneous conductive parts, the answer is 50 volts. The regulation says supplementary bonding is needed to keep the voltage lower than 50 volts. So I did this measurement here. Now this is on a socket outlet circuit on a C32. So times 10 for the current that could flow, potentially maximum for the minimum for the duration of 0.1 seconds, 320, the C-type multiplier. And I got 0.156 by calculation with Ohm's law. And I measured 0.15, so that's bang on the money. Bang on the money. Obviously, if there's an RCD present, then that gets us out of the problem with the 1667 adjustment. But this is something we need to be aware of more. Many circuits still don't have RCDs, especially for fixed equipment. Yeah. Coroner's Rule 43. Thank you, Richard. There we go. Yeah. Look up that and you'll see the coroner's input and it goes through there. And so when you're working, and when you're doing an EICR, this is why it's important to know the utilization of the building. You see a piece of equipment, where is the user when they're using it? What can they touch and what else can they touch? Is there pipe work? Is there a radiator? And so I personally, when I actually walk around, I will look at a work position or a station. If I do a ZS test or anything like that, while I'm reporting it, I will try to not do a drawing necessarily, although you could do a drawing of each work position, but I would try to find a way to record the value of voltage at that place of work to the exposed extraneous conductive parts. This is only if they can touch them. Don't say, oh, they could go over there and touch that. Only if they're likely to make contact with them. Okay, and it's a simple use of regulation 415.2. Okay, but think about that. Think about supplementary bonding. Think about the fact that it's not a yes or a no question. The question is, can more than 50 volts be present in that position exposed to the worker? In this case, with this socket, that value of resistance I measured, and you can see how easy it was to measure, was bang on the money if there was no RCD. I can't actually remember if there was an RCD, to be honest, but it's fine because it's bang on the money. If that resistance obviously was any higher, then obviously the voltage is going to start to climb. So
the issues with these places is obviously, first of all, it's an industrial commercial place, so there's not always RCDs. Some of them do have RCDs, some of them don't, and you have to be, you have to have a look to see what the circuit is, what the circuit protection is. The other thing you get with these things is you sometimes get these stainless steel tops where they will be plumbed in, they will be connected to the water pipes and stuff like that, so they will be providing a path, so they are actually an extraneous conductive part. But then you also get just tables which have got no connection, so they aren't an extraneous conductive part. So if they are an extraneous conductive part and they're not, you need to do this test to check your connection, check your continuity, okay, and do your calculation. If they're not an extraneous conductive part, okay, you can actually find that again by doing a resistance measurement. If you had done that resistance measurement and you had a value of over sort of like 22,000 ohms, then it doesn't, it doesn't constitute an extraneous conductive part. And this is one of the issues, isn't it? You go into these kitchens sometimes and you see that somebody has actually over bonded. They've actually put little pigtails on all the stuff that is extraneous and then connected it to the stuff that isn't extraneous.
And that's why
you need to have a bigger understanding of this issue.
Yeah, and that is why I've kind of added this, because people will ask the question of do you or do you not need it, and they just think about if it's metal and I can touch it, it must be that. The answer is 50 volts. If the voltage is greater than 50 volts, we must install supplementary bonding to bring the value of voltage down below 50 volts. That's the reason. So a lot of us don't think of Ohm's law when we think of supplementary bonding. We're looking for a yes or a no decision process, or we look for a book that says, oh, in these cases you do, in these cases you don't. It's just, using the regulations, it's just an application of Ohm's law, which really all you need to know is, take an R2 value. And I have to say again, for readily accessible things that the user is going to touch, there's no point starting to find points of contact the user won't use, because that's unnecessary. It's got to be realistic. So I find I cover this. This kind of thing needs to be brought into the training more, I think. And the reporting needs to have this kind of brought into it instead of it just being a tick. Because when you make things a tick, it just takes away the a lot of the attention for that from the inspectors. They just look at things and they don't really actually understand what they're trying to determine when they do that. So again, supplementary bonding, 50 volts. Right, some and just says a lot of these metal counters are pushed back to the wall and make connection to metal pipework that is clipped along the wall, especially in commercial kitchens. Just simply by being pushed into contact with? Yeah. And there could be, again, if you want to determine if there are potentials, you get your R2 lead out, and just like I've done there, I've just plugged in the R2 adapter into the CPC of the socket and measured that to the exposed conductive parts, or the things that you think may be exposed conductive parts. If you have a resistance value, it means there's a potential there that under a fault condition, from the source of energy, which in this case is a socket, but whatever the equipment is, you find out what the value of current could be in a fault condition, which is the maximum required to achieve disconnection time, basically. You could be more accurate, to be fair, and measure a live to earth loop impedance. That would be more accurate, because, it could be more even. But yeah, you then just plummet into Ohm's law and you're looking for 50 volts or less. If you have more than 50 volts, then you need to either find a way to bring that away, or if it can't be moved, then it may need to be supplementary bonded. I don't know. If there's a potential voltage there over 50 volts, it would need to be bonded, which is that regulation.
Or fit an RCBO.
Or fit an RCBO, yeah, which is a lot of the solutions to these problems. Right, let's look at some...
But remember, the thing also with RCBOs and RCDs is that they'll only work if they're maintained. So sometimes we use them too much as a safety net and then ignore them. And this is... over-reliance on RCDs and RCBOs is almost as bad.
Yeah.
Yeah.
All right, we're gonna crack on with some illustrations of things and just talk about the condition of things. Just a little coding discussion, just to kind of see if we kind of agree or what we can see in images. I can see some of you guys are talking about fire, which is great. You're coming up with a link to the Rule 43 letter. That's great. I'll go back there and have a little read, see if there's anything I can learn from that. I do like it when you guys kind of, we did this with the thermal image and you guys kind of started talking to each other. That's fine. Yeah, but we want to finish this webinar soon, don't we, Pops? Let's get a couple of these pictures.
We don't really want to go to number 3, do we?
No,
yeah.
No.
Right. Caravan park?
All right, yeah. So we do some work in caravan parks, and so we had a couple of images recently from these. This is a very typical caravan park hookup point. 16 amp socket. You can see there's a 16 amp overcurrent device, B type. There's an RCD. Obviously, regulations require individual protection for these. There's no information here on the earthing system, but it's most likely not going to be a PME, hopefully.
Hope.
Clearly, the enclosure is only accessible with the use of a key or a tool. I mean, you have to elaborate what a tool is, really, because that's anything in your hand will probably undo those things. But yeah, a tool. The only real problem we see in here is obviously we've used black as neutral. So identification of the conductors and the lugging. So short of a bit of improvement there, C3, there's little potential danger there, as long as obviously, impedances are correct and test data is correct. The question really, and I'll throw this your way, Bob. When we used to have the 4 codes, that code 4 does not comply with BS7671 would often result in pages of information in front of a client, which basically meant nothing with regards to safety, but more, it doesn't comply now. When we have things like C3s, would you agree this to be a C3? The potential incorrect identification of a conductor or the wrong conductor being used, as is commonly known?
Well, it's identification of conductors, isn't it?
Yeah.
So yeah, it'll go down
The
as a
514.
C3. Okay. If it goes down as a C3, what will normally happen is it will just get ignored anyway. But at least it's been highlighted. It's been included on the report. In this case, there is little danger because obviously somebody's just used a 3-core armoured, and whereas we sort of said about deneutralising black and using the black as the earth and then sleeving the grey up as a neutral, put some blue sleeving on it. They haven't done that. We had this when this first came in, when we first changed to these harmonised colours. You used to go to fuse boards and you'd see all sorts of colours in neutral bar, blue ones, black ones, grey ones, there's all sorts of stuff in there, like a multicoloured swap shop. The potential risk, well, is identification. Right? It is clearly been used as a neutral there. The risk would be is if somebody changes the other end without referring to this end. Yeah. So this is always the problem. Okay. It is a C3. It is not dangerous as it is. Okay, it is a C3, but in some cases you might look at this and think, well, and we've had this before working on big jobs where one team of guys are doing one end, terminating one end of a cable, and another team of guys are terminating the other. Yeah. That becomes a bit interesting if one set of guys are working to one set of rules and one set of guys working to the other. This is why we should have had proper legislation, proper sort of direction when these colours came in to say, look, do not use the black as a neutral. Yeah, there wasn't enough. There wasn't enough. There was hints and rumours, and the NIC said we're going to deneutralise black, but nobody actually banged the table and said, right, this is how it's going to be. You will use this colour for this, and you will use this colour for that, and you will sleeve it up. Yeah. Okay? And this is one of the issues. So, the simple answer to this one, it's a C3. So it's identification of conductors. Okay. Is that of any hazard? Well, it could be if somebody changes the other end. And this is always the thing you've got to think about. Well, for me then, I would ask, the client, if they get electricians to do the work, if they do, then there's probably no risk further down the line. If they do it DIY, then that would probably be more of a concern. Okay. The trouble with C3s, they get ignored, don't they? They do, yeah. And that you kind of feel like there's no point to it if you just fill them with a load of C3s. But if it's on the report, hopefully any subsequent electricians coming in would, hang on, it's on that report there. They've used the wrong colours. Okay. So these are all fed from a larger panel, like this one. This is obviously a large panel. Now, clearly here we can see on the left that these are locked up. So there's no access for the public here. Again, it's a key. What we've got here is obviously we've got armors feeding in to the top there of this isolator, and then going out the bottom
feed onto another one. So it's basically like an isolator that is passed through. So it's passing through this. So one arm coming in, and then it goes out the bottom to feed onto the next. So this isolator would shut that next one down. But then also just taking out of L2, I think it is, you can see the top of the black there, is a feed to the double pole switch to the left. So that's feeding this panel, and that then goes down to this little mess where we're looping to a double pole MCB, which caravan parks require double pole in case, obviously, the person putting in the hookup point has made up their lead with reverse polarity. Yeah, so caravans or caravan parks should have double pole protection on an MCB in case your hookup lead is of reverse polarity, basically. But what we can see here is we've got a loop into a double pole MCB that leads into an RCD, then leads to another. And so we've got this loop underneath and then up to the top one. And then out the bottom of each of these, or at the top of each of these devices is one of these at the bottom here. 1, 2, 3, 4, 5, 6, 7, 8, 9 cables. And those are the ones that go to these hookup points here. So it feeds 9 hookup points. But when we look at what we've got in here then, we've got one caravan hookup point which has just got overcurrent protection on the cable feeding it. Then the next one has just got RCDs. So it's a bit of an abomination, really. This is, and
there's no sense to that, is it?
Isn't it? It's a bit like a Frankenstein. It's just a load of DIN rails have been put in, and they've made a panel.
It's almost as if they thought, what have we got on the van? Well, we've got a number of RCDs, and we've got a number of double pole MCBs. So okay, that's just about enough to feed these 9 points, and we'll sort of swap them. We'll do one of these, and then one of those, and then one of these, and one of those. So you've got overcurrent protection on half of it. You've got RCD protection on half of it. Yeah. It's a complete mess. So
yeah, I mean, I anticipate maybe the RCDs have been upgraded as maybe over time. I don't know. It's not good because obviously the cables going under the ground to the caravans either don't have RCD protection or don't have sufficient overcurrent protection, one or the other in this situation. Ross says, are they all sharing the same One Earth cable? This is the fun that happens down here. So we've got coming off of the armor, coming into there. We're going over to the right. Then we've got this little taped up earth going over to this. So it's coming off of here to here, and it's coming over to here. And then we've got this. So if
connector block.
Yeah. So if this is the thing. So if it's all mechanically sound, it could just be that it needs improvement. But if there's any sign of corrosion or damage or anything, then that's potentially dangerous. Because all of these are feeding off of this cable. And then obviously the loops sequentially. This should just be replaced for a proper bar.
Yeah, the thing is, if that first connection comes loose, you're going to lose all the earths.
Steve says, could have at least used a Lego? Yeah, correct. Yeah. Caravan parks are quite creative.
That's one word for it.
Yeah. So it's all locked up, but the main question really here is, do we have the right protection amounts? Now in here, go back to the single. So the caravan connected to this has overcurrents, has residual current protection. So that's fine, technically, for everything plugged into that. But the cable feeding that, they also need necessary overcurrent protection, which these ones coming off of these RCDs, they do not. Right. Because there's no overcurrent protection in there, and there's no overcurrent protection in that. So the overcurrent protection for these cables on these RCDs going under the ground is basically relative to the overcurrent protection for there. So the only thing you could loosely say is, okay, is overcurrent protection needed if the demand is going to be no more than 16 amp here? Does that afford overcurrent protection because it's in line for these cables? What do you think?
Well, my issue with this would be, you've got those big, large cable coming in, feeding in top of that. Is that a circuit breaker? Or is that a switch disconnector? I can't really see from the...
What, this big thing here?
The big 3-phase one.
That's
just a switch disconnector, isn't it?
I think it's just a switch. Yeah, I don't think it's actually got overcurrent protection.
So there's no overcurrent protection going into that or coming through that. Okay, you've got the feed then going off that other one. Okay, So overcurrent protection on half of those outgoing supplies is non-existent. They're going onto armouds, which are then going down through the ground and then going out to feed caravans through the ground. So what if somebody hits one of those cables?
Right, so if you strike a cable...
So under short circuit conditions, what's going to operate?
Well, you're going to have a current relative to the impedance of your path, which is going to be fairly low because it's going to be quite a high impedance in that pathway. And the overcurrent required would be substantial if the overcurrent device is actually back at the origin. You're probably talking, well, more than minutes, maybe hours.
So this lot's probably going to catch fire then.
Yeah, most likely.
Okay.
Yeah.
All right. Also looking at the outgoing armouds, they've been nutted and bolted. There's no earths on the armouring.
No.
They've been nutted and bolted onto a plastic enclosure, but there's no earth onto the armouring at all.
So what you're saying is obviously the CPC's here going into the conductors, but there's nothing going onto this.
They've used a third conductor as the CPC for the circuit, the outgoing circuit, but there is no armouring.
Yeah. No.
So and that is a requirement. You need to earth those armouds because they're an exposed conductive part. So that's another C2.
Yeah, and Chris has noted this issue with the neutral.
Oh yes, splitting the neutral. Someone's
got a little bit heavy-handed there, slicing down the stripping. Yeah, so this is this is just a good example. Would you see any C1s in here though? Bear in mind, it's normally under a lock.
Immediately dangerous. No, probably not. No. It's all C2s. That top one there, which is those cables there again, they're not protected, are they? Because that's just an RCD.
Just an RCD.
And I think that's fed off of that. If you look at the loopy loops at the bottom.
Yeah, it's off the loops.
It's coming off of that hand, the bottom of that right hand one.
Into there.
Yeah.
Yeah, they're part of this fun here. Basically, they've run out of space, so they went up here to carry on.
It's come out that right-hand side one, up over to the top, and then to that RCD, and then away to another circuit. So again, there's no overcurrent protection on that.
So to conclude, then we've got no necessary overcurrent protection for this cable here. Because this obviously you can see this large cable's probably got overcurrent protection from its supply, but then this smaller cable coming out the top has no overcurrent protection. We've changed the size of the cable. And we know in the regulations, whatever the current carrying capacity of the conductor is changed, whether it be the cable size or even the environment that it's in, there should be installed a overcurrent protected device. That's under chapter 43. So there should be something there. Then that comes under here, and then that goes down to here. And again, there could be sufficient overcurrent protection here for these double poles, but would they need RCD protection? We don't know. If this is a TNS, maybe. We don't know what the earthing system is here. Anticipates probably a TNS.
There's another one that I'm not keen on, is the fact that when you look at those connections, a neutral connection, you've got two cables in that one terminal. I'm not happy with that.
Manufacturer may not even like that.
No, they're not made to do that, I'm sure of it. And if you start putting more than one cable into a terminal like that, it's not going to do up properly, so you're not going to have a proper connection. One of the guys just made a comment, the fact that if the RCDs trip, you need to access that panel to reset them.
Yeah.
So if you access that panel, you've got access to live connections.
So I mean, none of these are time delayed or anything, are they? No, these are just generic domestic. So there's nothing saying that this will trip independently of one of these.
Yeah, and there's no barriers in there. There's no barriers across the live barriers.
So potential danger there.
Yeah. So it's not a good job. I don't know why you. I don't know why you did that. Honestly,
I don't know. Wasn't my proudest moment, that one.
You need to step up. Yeah, mixed manufacturers again. You know, we've got a range of different units there. So it's not a great job, is it? It's not a great job at all.
No. So we're gonna. I mean, we won't label them all, but we've got about half a dozen probably C2s in there. Okay. What about you? You know the history between this one. What's this?
Can't see anything wrong with it. This is a caravan. This is again a caravan park. This is a supply to a caravan.
Mobile home.
We're talking about a mobile home.
Mobile home. Don't call them caravans. Mobile home.
Yes. We went out to this site. We worked on this site a few times, and the guy rang me up. The owner rang me up and said, "Can you come out and connect the mobile home up? We've got a unit that needs connecting up." So I've gone out and I've opened up the cupboard where the meter would normally be, and you're faced with this. Okay, now again, we've got a Caravan hookup position out by the gate to the garden, and in there we've got a 20 amp circuit breaker.
And that's the key thing. I mean, the Caravan
RCD,
like you saw in the previous where it was a 16, the Caravan site or mobile home site does say to all of the new tenants, you get 20 amps.
Yeah.
But these new mobile homes these days come with fully loaded boards, you know, and as we can see, 16 mil or 25 mil freaking tails to go on the end of your 2.5 mil armored. Yeah.
So when you look at this initially, you think, "Oh, goodness me, you know, the size of those tails and the size of the armoured, there's something wrong there." Well, actually, the armoured was perfectly okay for the size of the circuit breaker, the overcurrent protection behind it.
Correct, Steve. So, static property.
Static property, yeah. So the armoured is okay. It just obviously the static property comes with these huge tails, and you've got to make some sort of connection between them. And this guy had done it as a temporary by whacking it into a connector block. Various issues with that. And actually, he said to me, he said, "Well, can't we leave it like that?" I said, "Well, I don't think so." The twin and earth was going out to a shed.
Yeah, that was this. What would happen? Obviously, they would connect in the supply properly, apparently like this. But then, obviously, then the tenants would use the garden hose, twin and earth to their shed, where there's a load more power.
Yes.
I mean, our observation of this really is this is going to pull more than 20 amps quite often, quite regularly. And that does mean that through this connection onto that 2.5 mil, there will be some heat generated at that connection.
Yeah.
And this is obviously combustible material that this is mounted onto.
It's fixed onto a chipboard,
Yeah, and so that was kind of our conclusion, that this is going to be quite a warm connection. Even though the cable there is huge, the smaller cable it's going onto will get warm. That connection will get warm, and it's just not a suitable connection. The connection itself is in a little utility cupboard. So that's not a problem technically. It could be better though. It could be enclosed still. Especially if, again, here's the thing. This water hose was installed, I believe, by the tenant of the static home.
Of course, yeah.
So everyone's got a triangle key.
Or a pair of pliers.
Or a pair of pliers, or a screwdriver with the right size. And so that connection needs to be further enclosed, in my view.
And that's what we did.
Yeah.
That's what we did. We actually put it into a metal enclosed disconnector, basically, because we had the overcurrent protection from the supply, and we had the RCD protection there, but we just wanted to put it into a metal enclosure and do the connections properly. And that's what we did. The actual shed supply, we had basically a little two-way garage unit, metal garage unit we put up.
Right.
So we actually put the shed supply off from the circuit breaker, so that had its own overcurrent protection.
Mickey Molly says, what would you code a type ACRCD that protects DC components? Well, it depends really on the behavior of the DC components, in my view. I mean, if the DC components are potentially going to have leakage current that is DC in nature, and if it's likely to potentially impact the effectiveness of the RCD, we might be, trying not to say we will be, but we might be eventually in the next 5 or so years tipping into the territory where a lot of ACRCDs will be considered as temporarily dangerous if the equipment connected to them makes them defunct. So, yeah.
But does it not depend on what it's supplying? Completely. Because if it's a circuit that requires RCD protection, then obviously it's not to standard, so we'd be looking at a C2 probably. And if it's a circuit that doesn't require RCD protection, but you put it in there anyway, then arguably if the RCD doesn't work, as long as the overcurrent protection works,
this comes back to the.
It might then go down as a C3.
Yeah, I mean, Mr. Meanan's in the chat. He'll have an answer for this, but this comes back to our discussion we've had in the E5 group. We need to get more of an understanding on the characteristics of the equipment we are introducing to our systems at the design stage. And if you have an ACRCD right now and you install it in a brand new installation, you're basically restricting the potential future consumer behavior for the client, because they can't buy certain bits. We are really now in Type A territory, I believe. So it doesn't really, the industry will sooner or later start having this trend, if we look at what the rest of Europe is doing, of having ACRCDs not being liked. I mean, we've already got that in BS 7909 since 2011. It's been like that, not recommended. So if you're thinking about, the point of an EICR is to consider the condition of the installation and then, considering it being used further. Oh, I'll come back in 5 years or 3 years or 10 years, so it's like an in-service check. And if the future suggests an increase in DC equipment, it does suggest that you may want to come back and assess the RCD or just upgrade the RCD eventually. We're going to have to start talking about that more and more eventually. Let's move to this next lovely picture. What's happened here?
Oh, yes, okay, yes. So here we have a pit. Okay, this is a set of ductwork which feeds out. This is a sporting venue that we know. And this is outside. This is for supplies for marquees and various other bits and pieces for caterers outdoors.
Are these 63s or 32? What are these, 63s?
These are 60. I think these are 63. Yeah.
3-phase.
Yeah. So these are a little bit wet. Yeah. So they're in pits. The cables go through ducts. The actual sockets are mounted inside the pits. Okay. And obviously the pits fill up with water. So these are IPs. I think these are IP 65. Possibly. I can't see without having the cover on it. But anyway, obviously, even IP65, they're not actually manufactured to be underwater. And at some stage, the water has actually come up over the top of these. So the IP rating of these is not adequate. One of the issues we have, and an electrical firm had been in and looked at these and said, oh, there's no damage to them. Okay, they'd taken the covers off the sockets, looked inside, so there's no damage, there's no rusting, no signs of real corrosion, they're okay to be used again. Fortunately, we'd been called in and we actually took the box off the bottom. If you look at the bottom covers, the armoured cables come into the bottom enclosure, and that's where the armouring is terminated. And the armour
was that a bit rusted?
It was rusted to heck, on one of these, we had an earth loop impedance of about 65 ohms.
Gary, they're upside down, I believe, correct me if I'm wrong, because of the bending radius, because they're quite large cables, and if they were the right way up, you'd have to get underneath them in the pits and then come up and into them. So they're upside down, so they plug in instead of going underneath them and shoving them up.
Yeah, they've been installed upside down for access.
That's why they're upside down. Good observation.
So the issue here is, as I say, a firm had been in and said, oh, these are okay, there's been no damage to them, they just need a bit of a clean, a bit of a dry. And we'd come in, this was actually prior to an event when I was doing a test on it, and what we found was when I tested the circuit to see what the supply was to the marquee, and hang on, we got an earth loop impedance of 65 ohms on this one. The other one was still okay. We had an earth loop of about 0.6 or something or other. So we got 0.6 on one, 65 ohms on the other one. So the old spider sense, oh yeah, there's something wrong here. And when I took the cover off the bottom, it was absolutely rusted to heck. So again, when we're looking at this sort of situation, we've got to do a thorough inspection. Okay, by taking the cover off the bottom and inspecting the bottom connection where the actual armour is terminated, we found that the gland and everything and nut was just rusted through.
Cheers, Daniel.
So that's the sort of situation. It's the wrong IP codes for that sort of environment anyway, because if it fills up and the water comes over the top, then it needs to be a much higher rating. We need to be looking at IP67 rather than IP65. Okay, and that will include the bottom enclosure as well as the top enclosure. It's no good having the top enclosure IP65 and the bottom enclosure IP44. The water goes in the bottom enclosure, comes up through, and fills the thing up. So, so that was the issue with that one.
Okay. So, Last couple then. All right, so this one just talks about the need for us to understand prior editions of BS 7671. We mentioned this at the beginning of this presentation, which we did last week. You know, for us to do an EICR, do we need to understand how prior editions were, what technologies, what methods may be there, for us to then determine, you know, if they are dangerous or if they're okay to stay in place? This obviously is a VOE-LCB, a voltage-operated earth leakage circuit breaker, which I believe the Part P guidance says just leave as is, but we should obviously install further RC protection if they are in position. Now, with this example, the electrician thought it was an RCD and replaced the board without actually installing RCDs because he assumed that a VOE-LCB was an RCD because it had a big test button on it. So a lacking of understanding of prior devices, prior regulations actually created this situation. You know, so we could also think about things like cage bonding and things, and how BS 7671 in previous editions has gone down one avenue, and then as it's obviously developed in technology, we've started to adjust. There is potential for our lack of prior edition knowledge or prior technology knowledge for us to actually see situations like this in the future. So that's what this illustration really raises a point on.
Yeah. Well, that's an interesting point, because if you've got your modern day apprentices who are now training to the 18th edition, if they go out, once they finish their qualifications and they go out on jobs, okay, they might go to a job and they look at something which has been installed to the 16th edition, okay, they may look at it and think, hey, this is really bad, this is a real problem, this is terrible.
I agree, Nigel. Yeah, I agree.
Because they don't have the knowledge, or they didn't have the knowledge of, well, actually under the 16th edition this was okay and this was okay. And so we need to actually feed that into the training. We need to say, look, okay, we're now being taught to this edition of the regs and these are the requirements now. However, under previous editions of the regs, this happened and this happened and this happened, okay? And if you see installations to this, it doesn't mean you've got to say to Granny, hang on, you need a total rewire, so let's give me all your life savings. You know, we can look at the installations and say, all right, this was okay previously. If there's been no alteration in the use, and I mention this with rewirable fuse boards. I know some people hate rewirable fuse boards. They're still in the regs. They still do the job. All right. What I hate more than rewirable fuse boards is gas companies and others going into a pensioner's house and saying that is illegal. That is dangerous. You're going to die horribly in your bed because it's going to catch fire overnight. You need to give us X amount of thousands of pounds to replace your fuse board and rewire your house.
Yeah, I had that issue. I had this issue last year with an electrician up in Scotland who rewires houses, and he took pictures of old boards and suggested to the public that old boards immediately equals danger. You know, and it's not ethical.
Because they don't. Yeah. And I've had this on a number of occasions. I've gone out to elderly women. On one occasion, I went into a woman's house and she sat there in the dark. Yeah. This is like 3 o'clock on a winter afternoon. She sat in the dark because she's turned all the electrics off, because she's frightened out of her life, because the gas engineer had been in that day to service the boiler and had written up a big report saying her fuse board was dangerous, this, that, and the other. And they wanted £1,500 to replace the fuse board.
Nice. It is
an absolute scandal.
Oh no, it's a shame. I mean, I remember when I worked for the local authority in Bracknell, I went to do a private job. It was basically a friend of mine's nan had issues, and she had Southern Electric had gone round to read the meter, and obviously the person who reads meters has been told, if you see these fuse boards, you give them this, and she basically been quoted like £6,000 for a rewire of her 2-bedroom bungalow. And they said the main earthing was undersized and everything, and she got all panicked and all worried. And I popped round there. Her earthing was absolutely fine if you did the adiabatic. The adiabatic said it was absolutely fine. The only thing she could have done was RCDs. So I put next to her board, I put an RCD in a little unit for a socket circuit. I said, you're now fully compliant. This is the 17th edition at the time. She gave me a piece of Jamaica cake, and I was on my way. Absolutely. She was scared. She was scared. of her own installation. She lived in that house nearly 30 or 40 years. It was immaculate. There was no evidence of overload. There was no evidence of excessive use. Her utilization was perfect still. She wasn't plugging in leads upon leads. There was nothing wrong. She also could have done with a new bathroom light because she had one of those remember those lights that were heaters?
Oh, yeah.
She could have done with a new one of those, and I just said, any kind of IP44 drum fitting would have worked at the time. And I think I actually gave one to my mate, and he got someone to do it. I was, I was too busy, but yeah, that was it. But people they do use this old technology as a method to kind of push that. And our lack of knowledge in old technology and in old devices does result in misinformation for the client.
Yeah, I mean, this particular old lady, I say she'd been quoted £1,500, and I upgraded her earthing and bonding. That's all it needed. Okay, I've checked all the fuses; they had the right fuse wire in there. And I said to her, "Have you had a jacuzzi fitted, or a sauna, or a swimming pool, or a hot tub?" She said, "No." I said, "Well, you lived here for 40 years." She said, "Yeah." I said, "How many fires have you had?" She said, "None." I said, "Well, you're not going to have a fire now, are you? Just because we've changed the colour of the book, As long as I said to her, if you look at getting any new equipment or start going down the route of getting a hot tub or starting some sort of massage parlour or whatever, then you might need to look at upgrading. I said, but if you're using the installation the same way you've used it for the last 40 years, you're absolutely fine. So that was it. We sat and had a bit of tea and cake, and that was it.
Going on, you mentioned about adding extra demands like hot tubs or maybe EV chargers. We may start to see more examples of this coming up in the future.
Oh, yeah. Oh, yes.
With loads. So what do we do in this scenario? Do we do an investigative study to look at their use, their demand, changes increasing in loads, or do we just tell them to call their supplier?
My first point of call to that would be to talk to the customer and say, what are you doing? What are you actually plugging in? What loading have you got? And the thing is you might do a walk around and you think, well, there's nothing in particular here. But you don't know. In the garage, they might have an inflatable hot tub or an inflatable swimming pool, which they get out and then they plug it in with a heater and filtration system and this, that, and the other. So it might be something that they use at certain times of the year, which has got a fairly constant load, and it's doing that damage. But when you go around, it's not visible. It's not there. So talk to the customer and explain to them, you're obviously having a problem with excess current here. What are you doing? Is there anything in particular? And give them advice, hint to them. Are you using hot tubs? Are you using a swimming pool? Have you got some sort of electric barbecue system that you have big parties or something? Is there anything in particular that you can identify as to why this is happening? Okay. Involve the customer. Talk to them. Get all the information you can.
Steve says the smart meter installers are apparently doing now is if the CU is within 150 mil of the gas meter, they're saying it's an explosion risk. It's one of the problems with authorizing lesser skilled persons access to that installation. They can be told, what to interpret by vision alone. See this, say that, and that's just crap. But yeah.
Yeah, British Gas.
Okay, the same installation here. We can see we've got an RC unit to the left, and we can see the cable at the bottom. We can see red. So if we can see red, that means there's no fault protection for that conductor. There's no sheathing around there. So we've lost basic and fault protection. This has to be considered as a C2, surely.
Yeah, at least, yeah.
There's one action. Yeah, there's no fault protection, is there? Yeah. If you've got access to a single insulated live conductor. Yeah.
I mean, it also depends on how big the hole is that that's going into.
Oh, with the ingress.
So if you have a look under there, if you can stick your finger up inside that, then it would become a C1. So yeah, I mean, there's not much good about that, really, is that installation? But
I've just noticed the cable going to the top looks a lot bigger than the cable coming up the bottom.
It's huge. It's huge.
So I'm not sure. I'm not sure what the overcurrent requirements are or are there, but
is that feeding a shower?
I'm assuming so. It does look suspicious.
Yeah.
And T&E to a plug top. Yes, Harry, well spotted. Yes, 29 to a plug top. Not suitable.
Yeah. Not suitable at all. Yeah.
This actually, I went to this house. This was me taking these pictures because I was asked to do. They were doing an installation under the stairs. They were putting a toilet in, and the fuse board was under the stairs. That was in their way, but they didn't let it get in their way. This image now you can see from standing outside the cupboard on the left. This is the undercover space. They've put this new wall in. There's the supply up, and the fuse box is actually over here. So it's now around this corner. So to maintain that board, you've got to get around this corner, and it's not maintainable. Yeah. VIR tails. Yep. Good spot. So maintaining that board, they actually cut a hatch in the toilet wall. I saw on Facebook this morning, there was a post on one of the other groups where a guy finally found the board in the bathroom where it was behind the mirror. And then he looked through the hole and all of the service fuse was down there. So, you know, there's no accessibility. There's no potential maintenance on this stuff. Okay.
What's the earthing strap on that incoming cable? Is that a proper one or is it a bonding strap?
It's a EC15, I think. Look at it.
Right, okay.
Not ideal.
And then you've got an MET, which hasn't got a label on it.
No.
Okay.
No.
It's a good job, isn't it?
Rocky, you sent me to that.
Huh?
You sent me to this one.
Did I?
Yeah. All right. Image on the left. We've got a light fitting, wall light fitting, no CPC.
Yeah.
Class 1 appliance, no CPC.
So that would go down to C2 then?
Hmm?
Dangerous under fault.
Yeah. What about the one on the right here? Cable underneath. So this is a connection under the floor. Now, it's under the floor, so it's not accessible.
Yeah.
So it's a void space. So are we going to give that a C2 or a C3? What is the potential danger here?
Right.
C2.
For me personally, I would C2 it. And the reasons are, okay, those terminals, they're screw type terminals. They can become loose. As the circuit comes under use, the cables heat up, they'll expand and contract, heat up, expand and contract. So those terminals could become loose. If they come loose, they could start to arc. Okay. If they start to arc, we've got a fire risk. It's underneath the floorboards, which are wooden. Okay, so you've got combustible material. Nothing around those connections. So the connections need to be enclosed, and they need to be a maintenance-free connection.
Okay,
that's a laminated floor. You're not going to be able to take that up for maintenance.
So we agree it needs to be enclosed. It's a C2 because it's not enclosed in the space that it's in. There's no fault protection on those load conductors again, and the actual connection needs to be a fixed connection, a maintenance-free connection if it's just under the boards with no accessible hatch. Okay.
Yeah, and the other thing I think is a comment there. One of the guys has put, people do the same thing but just leave Wagos on there. Think, okay, that's maintenance-free, that's all right, and just leave it open like that. The whole point about putting it in an enclosure is hopefully you'll have some sort of sheath grip on the enclosure to hold the cables in place, so there's no strain on the cables themselves.
They need to be enclosed. Wago actually have the old Wago, the older ones that we knew of. The Wago box had it was arranged so that they would fit and they would have sufficient support from mechanical strain, because we've got electrical continuity, but also to consider mechanical strain on the connection. And then now that Wagos have gone down this smaller, thinner profile, the Wago box actually has these little sleeves that you put them in the connection to maintain that lack of vibration, that mechanical integrity. It's got to have the Wagos have to still be fixed in position, so there's no risk of vibration on their connection. They do test them, but they're only compliant if you install them in the way that they instruct. And I've got a video on YouTube about that actually not long ago. Well, about 5 months ago. So yeah, they still need to be enclosed even if they are converted to Wagos. All right, last two pictures of one scenario. I've talked about this one before. This domestic installation. So we've got a board at the top and a board below. Supply going to the top board, then feeds the board below. What problem can we see here? Matthew, regarding the wall light, if the client did not want it rewired, if you were to replace the luminaire with a class 2 luminaire, that's absolutely fine. Yeah? If you change the luminaire, as long as the class 1 accessories are changed to class 2, then that's fine. But you need the client to be informed of that moving forward.
You need to label the board and do a report and inform the client.
Yeah.
If you've got no CPCs on the lighting.
Same with light switches, and this is the thing. Clients can easily go down to the B&Q wholesalers, buy anything they want. So they need to be labeling, or they need to be well informed of that risk.
Yeah.
If you can do that, and you're happy with its control, mechanisms, then fine. All right, what we see? One means of total isolation, doubled up on income. We'll look at the neutral. Okay, so let's see what we can see here. Okay, and I took this picture because I just had to stare at it for 5 minutes ago. That's not right. Supply comes into the top main switch here. We then feed the bottom board from this supply side of this isolator, but the neutral feeding this board is actually from the neutral bar. So if I switch this top breaker off, but keep these on, what happens to this installation down here?
Everything goes off.
Broken neutral, switch neutral. Yeah, good. Yeah, so you have to really stare at this to kind of understand. So the system, this board here is going to shut off, this top board, when this goes off. This board here, every circuit is going to go off because this switching operation has obviously disconnected this neutral feeding the bar, which feeds this board down here. So we're going to single pole switch neutral when we switch this bar off. This whole board up here will go off. This board will all go off, but the live conductors will all still be energized. Yeah. We don't single pole switch neutrals, and that's what this situation has done. Yeah, there, with that little thing. This live coming out there, but the neutral comes out of the bar here, which is actually through this isolator. It's amazing. A tiny little thing like that can completely compromise the safety of a huge house. A little lack of concentration. And this is an electrical firm that put this in. We were there. There was a fairly new house. We were there to do work in the conservatory. We were doing work in the conservatory, and this was the existing board.
Yeah. The trouble is, it works, and that's the issue, isn't it? When you actually, from the customer's point of view, oh, everything's working. What a great electrician! Fantastic. And this is one of the problems I have with these, these sort of certain schemes where they say they rely on the customer giving you lovely feedback to say.
We've also got here. Is it Merlin Guerin or another brand? I mean,
there's a mixture, isn't there?
Why on earth can you not source MK? This is a 10-year-old picture. Why could you not source MK?
Well, they had those in the van, didn't they?
That's crazy. Right. That has actually look at that. We've completed the presentation, Pop.
Can't believe it, and it's only 6 hours.
It's only taken nearly 2 hours. God. All right.
Okay. Yeah. I mean, yeah. We've covered a number of points here.
We have.
The one that caused the most discussion was obviously the inspection item, the fire things. Yeah. And again, this comes back to, you've probably seen stuff that we've been putting on the network lately. Inspection is such an important part of the process. All the things that we've looked at here are all down to inspection. Nothing here was a testing thing. It was all down to inspection.
Yeah.
85%, probably more, of the items, the issues that you're going to find in installations are by inspection. And this is why I always say that even if you can't turn the installation off, if you're restricted, you can still do an inspection. And an inspection is a really, really important and viable part of the process of maintenance. So, when people say, oh, I can't do this because I couldn't turn it off and I couldn't isolate this and I couldn't isolate that, it doesn't cut the mustard with me. Inspection, do the inspection, spend more time on inspection, okay, and less time worrying about putting numbers into boxes.
Yeah. Awesome. I mean, there are things obviously like code breakers. There are things like guidance documents. They're all just that. We've got to try to argue for more time to do proper inspection, and we need to make sure we just always revise our own knowledge on what we're inspecting to then assess risk on that. we could do more of these. If any of you guys want to get more involved, engaged, or even come on and take part in this, we can do that. You know, you can talk about scenarios you've seen. No problem. You know, we're all kind of trying to just keep ourselves busy here. Duncan says we'd be good to include reg references to some of these things we've looked at. Okay, so that's another webinar we're going to do then, Pop. We're going to do some observations and how we actually find the regulations.
Yeah.
Okay, this is a great point though, because your knowledge of BS 7671 is critical. You know, we and I say that when I go to companies, a lot of the times when you lose a maintained understanding of BS 7671, you don't have to learn it off by heart. But if you lose a good understanding of the overall application of it, you then end up with inspection, just looking for a key half a dozen to maybe 10 things that you remember, and you lose the rest. So, we'll do that. We'll do some observations, and we'll add the reporting just so we can see how it relates. Okay. What else we got? So, all right. Cheers, Rob. Thanks for coming in. Got everyone's commenting there. Sean says, look forward to seeing everyone on Monday's workshop, 10 to 4. Oh, right, yeah, sure. And that's a course that we've got running. The idea of that, it's a course that we've put up for Monday. We're going to look at testing. We're going to look at the numbers that we get, like fault currents, impedances, and we're going to actually then determine, looking back at the regs, we're going to reverse engineer the results to then look at withstand calculations, adiabatics, to then interpret how they really can create dangers that we're not really taking in with data that we put on the form. When we put data on a form, there's a lot of information we're not using. And so we're going to kind of reverse engineer the testing, the data and the calculations and stuff. That's all on Monday. That's a course that we've put on. All right, would love an EV webinar. James would love an EV webinar. Well, I'm trying to get hold of the new code of practice so that I can reference that now that that's available. I shouldn't say, but I have had some information about a potential adjustment to Amendment 1 already, which I will look to finding a way to put in there because there are some errors. I shouldn't say anymore. Pete says, for those of you struggling to find a reg, 134.1.1 is my fave. Yeah.
My favorite is not a reg. It's page 2, which says that you've got to use your own skill, judgment, expertise in the application of the regs. That's my favorite part of the regs book. In other words, you know what you're doing, guys. Have the confidence to crack on and do it your way. Don't just be blindly led by what it says in the regs. It's the basis. It's the stepping point. Okay, level up from there and apply them the best way you think is possible.
Yep. Okay, all right. Everyone's saying it's been good. Thank you for saying thank you. Thank you for coming in. Raphael, the problem is customers don't want to pay for inspection, and far too many cowboys out there offering drive-bys. The public are not educated. I agree, and I think we need to start putting some of our time into discussing the best way to educate the public. One of the things we mentioned Michael at the beginning, the flesh creature guy, the third person of us, the person we always ask to do things. One of the things I've asked him to do on SparkyNinja is try to create this environment where we can collectively add information that is client advice that you can all then take back to your own personal websites and things. So, if we can come up with a consolidated way to do things, because client advice is key. And he's working, there's probably it's in the list of things to do. He has moaned at me every time I ask him to do something right now because he's got so much on. But it's worth it. It will be worth it. But I agree. We do need to start talking more about how we can properly talk to clients, educate clients, inspire clients. I've been saying this to Mr. Paul Meenan about our podcast. We've got to try to discuss, because he's a client. He says he's a client. We need to think about how to get clients to learn without just throwing regulations at them. Just without throwing legislations and things like that, because that just goes with many of them. So we're gonna try our best to come up with a good solution for that, and we will, fundamentally, we'll try and offer a platform that you guys can then get on, and we can get some stuff done on there, because it's very important. It's worthless wanting to do a good job if your client is not going to let you do it. What's the point? what is the point? So we've got to find the right way to educate clients, or speak to people that clients listen to, and not the badges, because they don't really relate to the badges. They're more of a procurement. It might be, we'll look at procurement, we'll look at insurance, we'll look at trying to speak to the right people to get them to listen to us on this, because this is what we need to do. Rightio. All right, thanks everybody.
We made that last 2 hours, that 45-minute webinar.
Sorry. Hope you had no plans.
As always, yeah.
We really
okay.
Yeah.
Thanks very much for your attendance. Thanks so much for taking part, and take care. Look after yourselves.
All right. Yeah. Everyone said thank you. No other messages. All right. Where do I have? Where's my button? There's my button. All right. Hang on. Was there any more questions? Hang on. Morning. All right, yeah, thank you, Eddie, thank you. Okay, where course? Oh, the course was Monday. It's on the, if you go to the website, the course is it's called 18th Edition Enhanced in Inspectors. So we're looking from an inspector perspective, Eddie. That's where that is. That's on the website. All right, guys, have a good day. It's Friday. It's a weekend. Hopefully it feels like a weekend. Hopefully, do something different.
Yeah, stay in.
Yeah. Oh, God. All right. See you guys later. Bye.